So let's see this question. Short binary linked list. So basically the problem description given a linked list A consists of n nodes. The linked list is a binary that is basically it's contains 0 and 1 only. So if we so basically it is given a linked list. We have given a linked list. Basically it contains 0 and 1s. So now given a linked list and you need to sort the linked list and return. Okay, okay. So if given a one of the test case, 1 is pointing to 0, pointing to 0, next pointing to 1. So we have written it as a 0 0 1 1 0. 0 is basically a null pointer here, so we can't return it. So yeah, basically we have to return this only. So the approach is very simple. We don't have to do anything, just we can traverse the linked list and keep a count. We can keep count number of ones and number of zeros. After counting that, we basically traverse the whole linked list and changing the data changing the data. So if we have here, we can see we have 1001, so we have two zeros and two ones. So while traversing linked list, we are here, we put 10, here we put 10, we change it to 0, we change it to 1, we change it to 1. Simple. So for code, we can see here, for that basically it is given. First of all, we have to return node A. Simple. For changing in, we make a buffer node. So for that, we are programming in C. So please take care of that. Structure list node pointer node buffer, and we make node buffer equal to our head node. Simple. So we need two variable integer type, count number of zeros and count number of 1, declaring it with zeros equal to 0. So now we have to traverse the linked list simply. So node buffer condition for linked list not equal to null. Basically it's not null, capital null. So we take a data, node data should be equal to node buffer pointed to its data. Simple. Now if node data is equal to 1, then we increment count 1 by 1. Else there are no other data like 2 3, so we can put else count 0 by 1, increment count 0 by 1. Simple. Up now again, while traversing node buffer same condition is equal to null. For terminating the linked list, we put no. First we check if count 0 is greater than 0 or not, greater than 0 or not. So we put node buffer is node buffer data is equal to 0, simple, and decrement the number of count of zeros by 1, simple. Same condition here, node buffer, and there is one condition I missed. For moving forward, node buffer should be equal to node buffer next, simple. Here node buffer data is equal to 1. First we have to put this number of zeros and then number of ones, simple. Then again same condition, node buffer is equal to node buffer dot next. Now checking, it shows the pointer. Okay, here basically we have to remove the struct list node. Now list node has no more as data, so oh actually it is value, we can't say data, it is actually value, it is value. Now running, null it's typo, null, it should be capital. Now we check whether our answer is correct or not. Yep, it is compiled. No, it's give a wrong answer. What is it? The function returning the following 101110000. Okay, let's check. We have a take account number of ones plus number of one node next. Okay, when count should be greater than 0, so it put 0, else it put 1. I think it is returning 1, then 0, then 111. Wait a minute, can we return a node buffer here? Yeah, node buffer is pointing to the next node buffer, so we can't return it. It's not changing. Node buffer value should be 0, then count 0, then node buffer value should be 1. Suppose it should be A. We don't take node buffer. We are moving with the A. Now check it. Nope, it's not like that. What? Printf count modulo d count 0, run. just wait a minute, slash n. It should be 1. It should be 1. Yep, it is correct. For the custom input, enter the linked list first. Number of nodes, we have number of nodes 6. 1 1 1 0 0 0. Let's test it. 1 1 1 0 0 0. We have a count 3 here. Okay, now for let's comment this out and run. It's again printing the same values. I don't know. Node. Oh, yeah, I got it. Basically, we have node buffer. Again, we have to shift to A. Now it should submit. Yeah, submit it. Yes, it is submitted. So thank you.